In the video on PCI enumeration, we discussed that enumeration is a process of detecting PCI devices. This process starts on power on. We assign the address of each and every endpoint. This address is in the form of bus device and function number, and this is configured in the configuration process of bridges. Host also identifies the features of the device by reading the configuration space of PCI devices. And next point happens in enumeration is memory base address mapping with the system memory and as per the range. So we discussed about first 3 points in the previous video on enumeration. In this video we will discuss that how memory addresses are mapped to system memory addresses and configuration happens in configuration space of PCI endpoint devices and bridges. We have discussed many times that this is PCI topology, and let us suppose that this particular device have some memory of 4K, and it is configured that this memory of 4K is in the address space of 32-bit or system address space. Then host CPU need to map this address space in his system memory so that host can access this memory. Similarly, here we have this bridge device. In this bridge device, it may have its own memory space. That memory again need to map in the system memory, and depending upon the memory of the device which resides in its topology, the range of memory is configured in this configuration space. And here for this particular bridge, the memory range need to be configured depending upon the memory requirement of these 3 bridges and in turn of these PCI devices. That we will discuss how it happens next. We know that configuration space is of 2 types. For end devices, we have configuration space. We call it type 0 header, and for bridges it is of type 1. To access configure type 0 header, configuration type 0 transactions are initiated, and for accessing the bridges type 1 configuration transactions are initiated. Here in configuration for type 0 header, we have base address registers. We call it as bar 0 to bar 5, and we can configure memories. We can have up to 6 memory ranges in one PCI endpoint device if all the address space lie between 32-bit memory space. If some address space lies between in 64-bit memory space, then the number of memory regions will be less than 6. For example, let us suppose that we have one address range which lies in 64-bit address space, then we require 2 bar register to configure it, and 4 lies in 32-bit address space, then 4 registers for 4 memory regions and 2 registers for 1 memory region. So we will have 4 32-bit memory region and 1 64-bit. Similarly, for bridge devices, we have 2 bar registers, bar 0 and bar 1, for configuring memory space inside the bridge, and we can have memory base and memory limit. These registers are required to configure the memory range of the devices which lie in under this particular bridge. It includes this memory region also. Similarly, if we have bar IO by address space, this IO address space is also configured in the bar base address region. So this IO base and IO limit. We can have prefetchable memory base and prefetchable memory limit. So if memory is prefetchable, then it should lie in 64-bit address space. So for that, defining the range and limit and base, we have first 32-bit LS bits of are can be calculated from prefetchable memory base and limit, and upper 32 bits are configured here. So similarly, if we have IO base of 32-bit address space, then upper 16 will be configured here. So in short, for IO base of 32-bit, 16-bit of base will come from here and limit will come from here, and upper 16-bit we will configure here. Similarly, for 32-bit memory base, we will have base here and limit here. For 64-bit, 32-bit base will be from here, limit will be from upper 32 will be configured here. Once more, for prefetchable, 32 bits will be configured, base will be configured here, limit will be here, upper 32 bit will be configured here. For memory base, 32 bits memory base will be configured here, limit will be configured here. How it will be done, we will discuss next. And for IO base, 16-bit base is configured here, limit is here. If IO base resides in 32-bit memory space, 16-bit base will be configured here and upper 16-bit will be configured here. Okay. We discussed the bar address registers. So in header type 0 we have 6 bar registers, and in header type 1 for bridge configuration space we have 2 bar registers. So in this bar register 4 bits are read-only bits, and it is configured as per, like if bar registers can be used for configuring memory address space and IO address space. So if it is 0, it is memory address space. If it is 1, it is IO address space. We know that for legacy and PCI endpoint devices, we have IO address space, and when it is native PCI devices, it is only memory address space. And I also discussed about that 32-bit memory access or 64-bit memory access. If we the 2 bits, bit 2 down to 1 is 0, 0, it lies in 32-bit address space. If it is 1, 1, it lies in 64-bit address space. Bit 0, 1 and 1, 0 are reserved. And bit 3, if bit 3 is 0, it is non-prefetchable, and if it is 1, it is prefetchable. What does prefetchable means? The memory region whose contents are not changed or updated after a read. Let us suppose if we have a RAM and we can read that memory location many times and its contents are not changed. And if we have memory kind of stack, because as soon as we read the stack, its contents are lost from that particular memory. So stack is not a prefetchable memory space. Okay, for type 0, so what is the process? Host initiates a write transaction and write all ones on bar registers. Let us suppose this is 31 down to 0 and up to 3 bits are for configuring that this is memory read or IO read, or these are 32-bit address range or 64-bit address range, and this is prefetchable or not. And then what this is 31st bit. So what host does is, using software, it will write 1 in all memory locations. It is writing 1. This is reserve. It is read only, so it doesn't matter. So let us suppose that this is bit number 10, this is bit number 9, and this is bit number 15. So what host does is write all the ones. Write all one. This is first step. Second step is read back. Now it read backs the bar register. So now, depending upon the memory size embedded in PCI device, it will get the value. Let us suppose that when host read backs, it gets the value like this. What does that mean? Bit 0 is 0. It means it is memory transaction. Bit 2 down to 1 is 0. It means it lies in 32-bit memory space. Bit 3 is 1, or it will, let's say that it is 0. It is non-prefetchable memory. And we wrote 1 from 31 down to 3 or 4, but when we read it back, we got that 15 down to 4 is 0 and 16th bit is 1. What it implies that this is the size of the memory. How now it will be configured? Now let's understand the 2 raised to power 16. 2 raised to power 6 and 2 raised to power 10. 2 raised to power 6, what does that mean? 64, and 2 raised to power 9 is k. So it's tell that this particular bar register will be configured for 64k memory region. And so what next step is host will do is, now host knows that this memory space, the PCI device has the memory space 64k, which is mapped to bar 0. So what it will do is, now it will map it to system memory. And let us suppose that now host writes this value. Now it knows that all will be zeros. 31 bit, let us suppose that it is 0, so, and this is, let us suppose that it is 24th bit, here it write once. So what does that mean is, if 24th bit is 1, now let's suppose that what it will make. It will make a 2 raised to power 24, and 2 raised to power 24 will become 2 raised to power 4 and 2 raised to power 20, and it will make 8. What does that mean is, from here all these are 0, so let's understand that 6 of how it will become. 24th bit is 1, so the address starts at 8 megabytes. So I just want to write it in hex. All are zeros up to 16. I am just ignoring. Okay, all are zeros. So these are first 4 bytes, and up to 17 to 9, 16 to 19 is again 0. 20, 21, 22, 23 is again 0. 24 is 1 and all 0. So it is saying that this hex address is the start of memory which is associated with bar 0. So and it is mapped with the system memory. So this is the base address. So what host did is, host mapped the memory region with the system memory, and when system wants to access the memory of 64K, it will initiate the address, starting address of this 01000000 in hex. And up to what address it will go? It will go when 16 bit is 1. So address range will be, start address will be 0x0 1 to 0x01 01. So this will be the address for 64K memory associated with bar 0. Similarly, host reads all the bar registers and configures the base address of all the memories. So here, if we could get, let us suppose that we have that bit number 2 down to 1 as 1 1. It will tell that it lies in 64-bit address space. So what does that mean is, host will write, see, the process will be same. Host will first write the 16-bit, and again, if address required for these bar registers are less than 4 gigabytes, then we will get that address range from 32 bits by itself, and then we need to write that upper 32 bits that we will write in next continuous base address register. Let us suppose that we find that when we are host is reading and writing all the base address register for first 0 1 2, it finds that it is 32 bit address space and it configured as per the process I explained here. But when it reads the base address register 3, it finds that this lies in 64-bit address space. So first procedure will be same. If it finds that address is less than 4 gigabyte, it will do all these steps which I explained here. But now after that it will read that base address register 4 also, and in that it will configure the upper 32 bit of the base address. Let us suppose here address was this 01000000. This was the base address for 32 bit, and if it is for 64 bit, then it will add some more 32 upper 32 bits also. It may be anything, like let us suppose that it may be FFFF0000. This is the it can be the start address of upper 32 bits of base address register, which will be configured in base address register 4, because in 3 we read and we found that it is 64. It should be mapped in 64 bit memory region. Okay, here I explained about that 64 bit. We can have separate example for this. Again, host will, I will not explain it in that detail. Host will write 1111 first. Host writes all one. Read back, host read back. It will find that bit 2 down to 1 as 11. What does that mean? 64 bit, and let's bit 3 is 1, and this is the 64 bit address space, and 1 it is prefetchable, and bit 0 is 0 telling memory. Now read back, and let's assume that again it finds that bit number 24th is 1. Before that 23 down to 4 is 0, and 24 to 31 are 1. If as 23 down to 4 is 0, it means that this particular bar register is associated with memory of 2 raised to 4 is 16 kilobytes. No, 16 megabytes, because so it is telling that this particular bar register is associated with 16 megabytes, and it is for 64 bit. Now host will configure first this particular address register, and it can say that okay, your base address 32 bits of lower 32 bits of base addresses are 0x. Let's suppose that it need to make sure that F000000 and 0. It is saying that the base address of of this particular memory range is this, and up to what address it should go. I'm just talking about at present lower 32 bit. It should go up to 24th bit should be 1. 3, 7, 9, 3, 7, 11, 15, 19, 23. 24th bit should be 1. Then it should come as 1. And this is the lower 32 bits of base address. This is the lower 32 bits of upper address. And now we need to configure the upper 32 bits of base address, and that will can be anything. So host need to configure here in base address register. Let's assume that host configure the value as FFFFFF0000. Similarly, so now what will become the base address? Base address will become FFFFFF0000 F00 5, 7, and 8. So this will become the base address in the 64-bit address space. Okay. We will discuss about type of address space. Here we have base and limit. how it works is, for IO also we have base and limit. How it works is, these are 16 bits of base and 16 bit of limit. So let's write the base here first. Let me write it here. Base. How we interpret the base? For IO, let us suppose that we have the value of, plus it is 7 down to 0, and how it will be here, let's make it 3, 2, 1, 0, 4, 5 and 6. So here in the base, let's suppose that we have written the value as 0, 1, 1, 0, and this last 4 bits tells that this IO base is 16 bit or 32 bits. So if it is 0, it tells that this IO address will lie in 32 bit, 16 bit, sorry. Or if it is 1, so okay, let me write it here. 3 down to 0 of IO base 0, it means 16 bit IO address space. If it is 1, then it is 32 bit. Okay, so now if it is 0, it means it is 16 bits, and here 7 down to 4 will make the value it is 6. So after that, what we need to do is, here we write 6 and we need to write 0, 0, 0. So it tells that this is the start address. So again, what I will tell is, we reach the base address at location 07, and it's bit 7 down to 4. Here it is 6, and we add zeros after that. And if 3 down to 0 is 0, it means it's 16 bit. If 3 down to 0 is 1, it means 32 bit. If it is 1, then this address will lie in 32 bit address space. If it is 0, it will lie in 16 bit address space. If it is 1, then 16 bits will come from base address. How it will come? It will take the 7 down to 4, write it here, and after that 3 zeros. This is for 16 bit address space. And how limit will be calculated? Here again, limit, we will have address space as 7, 6, 5, 4, 3, 2, 1, 0. Again, this will be read only. If it is 0, it means 16 bit. If it is 1, it means 32 bit. And 7 down to 4 will be configured like this. It will, like earlier, it is this 6. So 0x6. Here now we need to write FFF. So what will be the base and IO for 16 bit? Starting from 0x 6000 to 0x6FFF. This is the base and region. Limit is configured in the bridge register. So we can have IO of the IO address space in the PCI base device and in the bridge also. So combined address range will be configured here in IO base and IO limit. If it is 32 bit, then 3 down to 0 will have value 1. So what will happen? Process will be same for IO base and IO limit, and we have 16-bit upper. So we will have to configure the 16-bit upper base and 16-bit upper limit. So what we need to do is, we can, after that what we can do is, let's suppose that we write at address location 12, it's a decimal, we know that 0 correspond to 0, 1 correspond to 0, 4, and 8, 2 correspond to 8, and 3C 10 14 18 1C 20. This is hex address 24 28 2C 30 34 38 3C. So for configuring the upper 16-bit of IO address space, we need to write at offset of 30 in hex. And if we write, let's suppose that lower 16 bits are configured here. If we want to make it 32 IO space line 32-bit address space, then we need to write here, let's suppose that we are writing this, and that upper base upper and limit upper, then address combined address will become base will become 0x ff 00 6 000 2 0x ff 00 6 fff. Okay. Now we will discuss about the memory. This is for non-prefetchable memory. So here we have memory base and memory limit. Both are 16 bits now. Memory base is 16 bit. It is prefetchable, non-prefetchable. So 15 down to, let us put that 4, after that 3 2 1 and 0. Again these 4 bits are read only. And for memory base, which lies in 32-bit address space and non-prefetchable, this should be 0. Okay, and let's suppose that if we are getting the value here something like that 1 1 1 1, this is 15, this will be become 12, and 0 0 0 0, it will become 7 8, and 1 0 0 0. So it is F08. And after that, because this base should be of 32-bit, line 32-bit address space, so what we need to do is, for base we need to write all other zeros. So the base address for the 32-bit memory space non-prefetchable become F08 00 000 0. Okay, and now we have limit, memory limit. How it will become is, we have 15 down to 0. Again, because it is 32-bit and non-prefetchable, 3 2 1 0 should be 0, and 15 down to 4 will have the value which will be, again let us suppose that it has the same value 1 1 1 1 0 0 0 0 1 0 0 0 F08. This is base, and then 0x, this is limit. we need to write ff. So what will become is base is f08, limit is so what does that mean is if we check that value 3 7 9 15 19, so 20th, so this is for 1 megabyte. Why 1 megabyte? If we are checking that 20th bit will be up to 19th bit, we are it is FFF. If we can configure more memory range, the same, let us suppose that, then we will have to change that memory base address accordingly. Okay, this is for non-prefetchable. We have discussed for IO base. IO base we can discuss that IO base can lie in 16 bit or 32 bit. If it is in 16 bit, then only these 16 bits are required. If IO base lies in 32 bit, these 16 bits and address these 32 bits are required. Now we discussed in this that 32 bit memory space, then it will lie 16 bit, these 32 bits are required. Now we will discuss and we know that if it is 13 bit 32 bit, then bits 3 down to 0 will be 0 always. Now we will discuss about prefetchable memory space. In prefetchable memory space, this 3 down to 0 bit will have different values. It will tell that it is prefetchable memory space and it should lie in 64 bit address space. Okay. Now this is prefetchable memory base. Now we need to configure these registers for configuring the memory for prefetchable memory space. Again, first these 16 bits, 15 down to 0, bit 3 to 1 0, these are read only and it should have value 1. It tells that 32 bit, if it is 0 32 bit, that we had discussed earlier, it is 1 now, so it is 64 bit. So prefetchable memory should be in 64 bit address space and 15 down to 4. So upper 32 bits will come from that here, so that will be 31 down to 0. So if we want to make, so what will be, this process is same. Let us suppose that we write, we find the value at, or we configure it at 1 1 1 1 0 0 0 0 and 4 more 0 0 0 0. What does that mean? F0 0. We know that for base we need to write 0 0 0 0 0, and this is lower 32 bits and upper 32 bit can be any value. Let us suppose that it is 0 0 0 0 F 0 0. So when we combine both, it will become the 64 bit base. For upper limit, this 32 bit will be same depending upon the range, and here lower 32 bit will become F. If it is, let us suppose that this bit is now, we know that what is the range here is, we configure it as range will be which bit is 1 first? This 15, 19, 20th. 1 megabyte. Okay, we all know that concept of how we calculate this memory. I have discussed that in whenever we need to calculate the memory size. Here, if we see that 20th bit is 1. 20th bit is 1 means 2 raised to 20, which comes out to be 1 megabyte. Okay, so we have discussed about, again I'm saying that, how base address registers are configured depending on the size of the memory embedded in that particular device or bridge. It can be 32-bit. If it is 32-bit, then only base address register will be configured, only one. If it is 64-bit or prefetchable, both register need to be configured. And for bridge devices, we have IO base and IO limit. IO base, if it lies in 16-bit, only these two fields need to be configured. If it lies in 32-bit, then these two field plus address is at 1612 need to be configured. Memory base, this is for non-prefetchable memory base, which lies in 32-bit address space, and if it lies in 64-bit address space, then prefetchable memory base and memory limit need to be configured. And for upper 32-bit, we need to configure these memory spaces. Okay, just how it works, we will just understand. So here, host has initiated a enumeration process. Host configured that bus device functions and the bridge devices here, and identified the location of the PCI devices. Now, host also let that configuration space of PCI devices and understood after reading the vendor ID, device ID, class and subclass which kind of device it is. Now, host initiates that configuration writes to the bar registers. That process we have discussed, and then understand that memory space requirement and map the memory of the devices to the system memory. Once it is done, then host will go one step up and then will map that memory in that device PCI bridge device, PCI bridge configuration space, and also once it is done, then it will map that particular range into this particular bridge, and then it will map that in this particular bridge. So what it will do is, first host will configure the bar of PCI device 0 to bar 5 depending upon that memory available, memory size, and is it line 32-bit or 64-bit. Once this memory bar registers are configured, then host will configure the bridge for base and limit, and similarly for IO, if device is has IO, then it will configure IO also. Once it is done, then it will configure the upper memory. I think that's it. So now we understand that in enumeration, host identifies the location of the devices, features of the devices, and maps the memory of the device to the system memory. After these steps, PCI devices are ready to be used. So thanks all for watching this video, and if you have any doubt, please let me know. We will clear it. Thank you all.